So the images show a normal curve with a mean of 40 and a standard deviation of 2. The area under the curve to the left of 39 is 0.3085. The area under the curve to the left of 43 is 0.9332. Since it is a normal curve, we know that the total area of the curve is 1. Use the given areas to find the area in question. Explain the reasoning for each. So find the area under the curve to the right of 39. So what we want to do is we want to find the area to the right of 39. So in order to do that, they tell us that the area to the left is 0.3085, correct? Okay, I need you to bear with me because there's a lot of thought process. Whole curve is going to be 1. So if I'm going to define this black shaded region, I'm going to do 1 minus 0.3085. With me? Okay, so if I do 1 minus 0.3085, I'm going to get, I don't trust my math skills anymore. I'm going to get 0.6915. So that's going to be 69.15%. Now, question number 2 asks, find the area under the curve between 39 and 43. So looking at this again, we're going from 39 to 43. Well, we're going to have to use this part too, right? And we want to find between it. So what we're going to do is we're going to subtract this and this guy to find the between. Okay, so we're going to get 0.9332 minus 0.3085. And so that's going to give me 0.6247. So when you see the word between, you're going to subtract 2 numbers. If you see the words to the right of, you're going to do 1 minus whatever that number is. Those are going to be something that you're going to need to know. Between, subtract, to the right of, 1 minus whatever. The images show a curve with a mean of 40 and a standard deviation of 2. They give us that information again. Find the area under the curve to the left of 40. So this is a little trickier. Finding the area under the curve to the left of 40. They don't give us a whole lot of information, but they did tell us that 40 was our what? Our 40 was our mean. Our mean lies in the middle, correct? Is the exact middle. So if I want to find the area underneath here, isn't that going to just be half? So what's half in decimal form? It's not a trick question. 0.5. With me? 50%? 0.5? Yeah? Okay, cool. Cool. All right. Talking the same language. All right. Now, find the area under the curve between, there's that keyword, 39 and 40. Well, they told us 39 was this, and then we just found 40 here, right? So what are we going to do? We're going to subtract 0.5 minus 0.3085. And that's going to give us 0.1915. Ta-da! Okay, a survey indicates that people use their computers on average 2.4 years before upgrading to a new machine. Standard deviation is 0.5 a year. Assume that the variable x is normally distributed. So we're going to draw and label the normal curve. It's the same thing that we did last time. So let's go ahead and do that. So our mean is 2.4. And then they say that our standard deviation is 0.5. Okay, so we're going to add 4 lines. So 2.4 plus 0.5 is going to give me 2.9. 2.9 plus 0.5 is going to give me 3.4. 3.4 plus 0.5 is going to give me 3.9. And then 3.9 plus 0.5 is going to give me 4.4. On the other side, we're going to get 1.9, 1.5, 1.1, 2, 3, and 0.6. Ta-da. Okay, so I made that correction on that left-hand side. Okay, so if a computer owner is selected at random, find the probability that he or she will use it for less than 2 years before upgrading. Okay, so 2 years is going to lie on our normal curve right in here. Well, we don't have a percentage for that. So what we're going to do is we're going to use the z-score. Okay, so I'm going to clear this really quick. We're going to use that z-score formula. And so we're going to do 2 minus 2.4, because that was our average on the last page, divided by 0.5. Okay, so we're going to get 2 minus 2.4 divided by 0.5. And that's going to give us negative 0.8. Okay, this has not found the probability. The question asked us to find the probability. We found the z-score. In your packets, on the back of page 19 and 20, I need you to flip there once you get that written down. So once you're finished, I want you to flip to 19 and 20. And you're going to look at and see a bunch of numbers. And you're going to be like, what is this? We're going to talk about it. Page 19, 20 in your packet. Okay, yeah, it is a ton of numbers. Okay, now on your packet, you have a negative side and a positive side. So back of page 19 is your negative side. 20 is going to be your positive. I'm hoping that this is the same as what you'll have there. We'll find out. I think it's backwards. Give me this. So I'm going to get rid of this little drawing. On back of page 19, you see this table, right? Okay, so we're going to read this table together. What you always want to do is you want to start at 0, 0, which is down at the bottom on this page. Okay, and we're going to go to where it says negative 0.8. Okay, so we're going to go all the way up to where it says negative 0.8. And then what's the next decimal after that 8? What would it be? No. Look at the number that we just found. It's negative 0.8. What would be this next decimal? 0, right? Okay, so up at the top of your z-score table, you see this right here, up along the top. This is your second number. Well, our second number is 0, correct? So looking at this, then we would use this number right here. Boom. So it would be 0.21186. That means that the probability is 21.186%. This is your final answer. Does that make sense? Z-score tells you your standard deviation. The z-score table tells you your probability, your proportion, those words. Okay. It says he or she will be using it more than 3 years before upgrading. Okay, so on our little on our little normal distribution curve, 0.5. Okay, on our normal distribution curve, we're looking at 3 or more years, right? So we're going to find our z-score because it's not on our normal curve. So we're going to have 3 minus 2.4, and we're going to divide it by 0.5. So we go 3 minus 2.4, and we're going to divide it by 0.5, and that's going to give us 1.2. So now we're going to go to our z-score table, and we're going to find our proportion. Okay, so once you get that down, go ahead and use your z-score table. You're going to use page 20 this time because it's positive. You're going to go down to where it says 1.2 and go to the right one time over. Okay, so again, we're going to go to page 20. And we're going to go where it says 1.2. So we're going to start at 0, 0, go down to where it says 1.2. And we're going to go to the right one time. Now, when we did our little normal curve, and it says 88493, right? Okay, when we went and we drew our little normal curve, we see this little slither, right? Does this look like 88% of our stuff? No, it doesn't. Well, they want it to be above 3 years, right? In this case, we're going to say 1 minus that number that we just pulled from our z-score table. So 0.88493. So 1 minus 0.88493. And that's going to give us 0.11507. That's going to be 11.507%. Now that looks like this little sliver. So you're going to do between 1 and 2 years. These kind of questions are very long. Okay, so what we're going to do is we're going to do the z-score for both 1 year and 2 years. All right, so let's do it. We're going to do 1 minus 2.4 divided by 0.5. And then we're going to do 2 minus 2.4 divided by 0.5. So when we plug this in, we're going to get 1 minus 2.4 divided by 0.5. That's going to give us negative 2.8. On the next one, we're going to get 2 minus 2.4. We're going to divide it by 0.5. That's going to give us negative 0.8. Now, we're going to go to our z-score table, and we're going to pull the z-scores, or I'm sorry, we're going to pull the proportions for both of these. So take a moment, see if you can pull these proportions from the z-score table. I did. Yeah. Try it. You should be able to check and see if you did it right. So if you pulled these numbers from your z-score table, you should have gotten 0.00256 and 0.21186. Now this says between. So what we're going to do is we're going to subtract the proportions. So 0.21186 minus 0.00256. And that'll give us our answer. So 0.21186 minus 0.00256. And that's going to give us 0.2093. That's 20.93%. So if you're sitting there and you're like, why are we having to use this table? Well, back in the old days, they didn't have a z-score table and you had to calculate this all by hand and it was atrocious. So you're welcome. But I also understand reading that z-score table is a little tricky. Okay. Not really easy if you don't practice. All right. So what's going to go in the middle? We're talking about the GRE scores and the MAT. So let's do GRE first. What's the mean? 1,500, right? And then we've got a standard deviation of 300. So what's 1,500 plus 300? Okay. And then plus 300 again. Cooking right now? Interesting. All right, so 1800 plus 300 is going to give us 2100. Yep, that's right. And then 2100 plus 300 is 2400. 1, 2, 3. And then that'll give us 2700. And then we're going to subtract. Okay. Can you set up the MAT curve? So using 50 and 5. That one's a little easier. Draw this curve. You're going to have a mean of 50. And then you're going to have a standard deviation of 5. Okay. You decide to take both tests and you score an 1875 on the GRE and a 57 on the MAT. On which test did you score better? And this is kind of where standard deviation really helps when you talk about scores. Okay, so if you got 1875, what you're going to do is you're going to find the z-score on here. Okay, so 1875 minus your mean, which is 1500. We're going to divide it by 300. So we're going to take 1875 minus 1500, and we're going to divide it by 300, and that's going to give us 1.25. On the MAT, we're going to get 57 minus 50, 5. So 7 divided by 5 is going to give us 1.4. So which one is going to be a better score? Well, this says you're 1.25 standard deviations above the mean. The other one says 1.4. So you did better on the MAT. You could also look at the proportions, pull up the z-scores table, go from there. But you could also just see standard deviations wise, you did better because you had a higher standard deviation. Your friend also takes the score. So also takes the test and they score 1775 and a 54. Which test did your friend score better on? So 1775 minus 1500 divided by 300. And when we plug that in, that's going to be 0.916. If you want to round on that, that's okay. And then on the other one, we got 54 minus 50 divided by 5. That's going to give me 0.8. So which one did they score better on? The GRE, right? They had a higher standard deviation above the mean than the other tests.